Let's learn more about forces. You should have a copy of this gravity foldable. Fold it like an accordion, tuck everything underneath, and glue it in the composition book on the tab that says gravity. You will take most of your notes in this foldable. Gravity, we use a capital F and a lowercase g for force of gravity. Gravity is a force of attraction between any two masses. Which will hit the ground first, a feather or a hammer?
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Now let's look at Newton's law of universal gravitation. We know that the Earth is larger than the Moon, and because it's larger, it has a stronger gravitational pull. This means that gravity varies directly with the masses. So when mass increases, the force of gravity increases. We also know that an object's distance makes a difference in the amount of gravitational attraction. Look at Earth compared to Neptune. Earth is much closer to the Sun than Neptune, so the Sun will have a stronger gravitational pull on the Earth. Therefore, Newton's law of universal gravitation tells us that gravity varies inversely with the distance between the objects, meaning the greater the distance, the smaller the force of gravity. Now let's talk about weight. Make sure you're recording all of these notes on gravity on the gravity foldable. Weight is the force of gravity acting on an object. Since weight is the force of gravity, it depends on your location. If there is less gravity, you will have less weight, and vice versa. Now let's look at how to calculate weight. Since weight is a force, we can use the same equation we already know, F equals ma. But to find weight, which is Fg, we're going to do m times little g, where g is the acceleration due to gravity. The acceleration due to gravity on Earth is 9.8 meters per second squared. The units that we will use for weight, since weight is a force, is newtons. Again, make sure you have all of this written on your gravity foldable in the section entitled Calculating Weight. Now we will work the examples on the back of the gravity foldable. We will start with this one. As usual, start by writing down the information that you know. On this problem, it tells us that the mass of the astronaut is 95 kilograms. We want to find the weight of the astronaut, and to find weight, we use g, which is 9.8 meters per second squared. F of g, which is gravity, is our unknown. So our equation is F of g equals m times g. Plug in your values, 95 kilograms for mass, 9.8 for g. Type that in the calculator, and you get an answer of 931 newtons. Now let's look at part B. Part B asks what is the mass of the astronaut on the space station. Well, mass doesn't change depending on where you are. So if the mass of the astronaut is 95 kilograms on Earth, then it's 95 kilograms on the space station. Part C asks about the weight of the astronaut on the space station. Since weight depends on gravity and there's no gravity on the space station, the weight of the astronaut will be 0. Let's look at the next example. This question asks, what is the mass of an object if it weighs 345 newtons? Well, if it weighs that much, that's the force of gravity, so that's Fg. And since we're dealing with Fg, we know that little g is 9.8 meters per second squared because it is on Earth. And I'm asked to find the mass, so that's my unknown. So write your equation, Fg equals mg, plug in your values, put it in the calculator, and you get a value of 35.2 kilograms for the mass of the object. Now let's look at the third example. What is the weight of a 20 kilogram stone? Write down your given information. The mass is 20 kilograms. We know that G is 9.8 meters per second squared, and since we're talking about weight, we have to use that. Weight is Fg, so it's our unknown. Write your equation, Fg equals mg, plug in your values to the equation, then put it in the calculator. You should get the weight of the stone to be 196 newtons. Now let's look at the last example. A crane is holding a 1,000 kilogram I-beam stationary. Write down what you know. The mass is 1,000 kilograms. G is 9.8 meters per second squared. The tension in the cable is going to have to be equal and opposite to the force of gravity on the I-beam. So to find the tension, we just need to find the force of gravity. So we will use our gravity equation, Fg equals mg, plug in your values, type it in the calculator, and you should get the force of gravity being 9,800 newtons, which is equal to the tension in the cable. Now let's talk about some other kinds of forces. We'll start with friction. Write these notes in your composition book. Friction is a force that opposes the motion of an object. It is always a resistive force, meaning it's always opposite the direction of motion of the object. There are several different kinds of friction. 4 in particular are static friction, sliding friction, rolling friction, and fluid friction. One specific type of fluid friction is air resistance. Air resistance opposes the motion of an object through air. It is worth noting that a fluid is defined as anything that flows, so gases and liquids are both fluids. You should have a copy of this diagram, included in your composition book. When an object is released from rest, the only force acting on it initially is gravity, which is the weight of the object. Make sure you are writing these notes on your diagram and in your composition book. As the object begins to fall through the air resistance will act on the object, creating a drag force in the opposite direction of the motion of the object. The longer the object falls, the more air resistance there will be as the object gains velocity. Eventually, the amount of drag force will be equal to the weight of the object. When this happens, the object has reached terminal velocity. Let's examine terminal velocity a little more closely. When an object reaches terminal velocity, the net force acting on the object is now 0 because the drag force and the weight are equal but in opposite directions. If the net force is 0, then the acceleration on the object is 0. Therefore, the object moves with a constant velocity, and this is called terminal velocity. We can sum this up by saying that terminal velocity occurs when the force of fluid friction is equal and opposite to the force of gravity.